In question 5, we have a diagram something like this, showing a filament lamp sending light through a narrow slit towards a diffraction grating. We need to complete the diagram to show the light beams transmitted by the grating, showing the zero order beam and the first order beams. Well, the zero order beam goes straight through, and there will be a first order beam some angle either side of this. In B, light from a star is passed through grating. We need to explain how the appearance of the first order beam can be used to deduce one piece of information about the gases making up the outer layers of the star. Well, the absorption spectra, which are the dark lines, are specific to the elements in the star's atmosphere. In C, in an experiment a laser is used with a diffraction grating of a known number of lines per millimeter to measure the wavelength of the laser light. In part 1 we need to draw a labelled diagram of a suitable arrangement to carry out this experiment. Well, we would pass the laser light through a diffraction grating towards a screen. In part 2, we need to describe the necessary procedure in order to obtain an accurate and reliable value for the wavelength of the laser light. Well, the distance from the grating to the screen should be as large as possible. This improves the accuracy. We can measure the distance to the screen and the distance from the zero order maximum to the first order maximum. Alternatively, if we measure the distance between the two first order maxima, dividing by 2, this will give a more accurate reading. We need to find the angle theta between the zero order maximum and a first order maximum. Using the tan theta will be equal to the distance between the zero and first order maximum over the distance between the grating and the screen. We can find the wavelength using n lambda equals d sine theta, where in this case n equals 1 as we're using the first order. D is the distance between the slits. This is found from 1 over 1000 times the number of slits per millimeter.